Today we are going to discuss about matrices. Okay, what do you know about matrices? This can be give as a definition in a proper way. This set of elements which are arranged in a rows and columns are called matrices. Of elements which are arranged in a rows and columns are called matrices. Whatever you said, that 2 by 2, 3 by 3, it is nothing but what? Order. Order is nothing but number of rows by number of columns. Number of rows by number of columns. Here rows is nothing but what? Horizontal line. Rows is nothing but what? Horizontal line. And columns is nothing but vertical lines. Here suppose I am writing 1, 2, 3, then 4, 5, 6.
2 rows and 2 rows and 3 columns.
2 rows, 3 columns. Then what will be the order?
2 by 2.
2 by 3. Correct? 2 by 3. Number of rows are 2, number of columns are 3. So 2 rows, 3 columns. And what about this? 1, 2, 3, 4, 5, 6, 7, 8, 9.
This is 3 by 3.
What is it?
3 rows, 3 columns.
3 rows, 3 columns. So well, observe the order of the matrix. We can able to determine how many rows and how many columns it will be consist. Am I right?
Yes,
Based
sir.
on this order, we can able to determine how many rows and how many columns it has. So now based on that order, we are define the types of matrices. Types of matrices. A matrices which is consist of only one column. See how many columns are there?
1 column and 3 rows, 1 column. No.
3 rows and 1
One
column.
column.
So this order is 3 by 1. Am I right? So this is called column matrix. This is the example of what? Column matrix. A matrix which has only one column is called column matrix. Got it? Now tell me how many rows and how many columns it has?
1 row and 3 columns.
1 row and 3 columns. So in this 1 row it has, so this is called row matrix. What is that? Row matrix. This is called column matrix. This is called row matrix. A matrix which has only one column is called column matrix. A matrix which has only one row, it has the row matrix. It is called row matrix. Got it? If in a matrix, number of rows, number of columns are equal, number of rows and number of columns are equal, then do you have any idea what is it called? If number of rows and square matrix. What is that?
Square matrix.
Square matrix. So for example, earlier we took that 1, 2, 3, 4, 5, 6, 7, 8, 9. How many rows are there? 3. Correct? 3 by 3. So how many columns? 3. So the number of rows and number of columns are equal. So this is the example of square matrix. And this, now tell me how many rows and how many columns it has?
2 by 2.
2 by 2. So here number of rows and number of columns are equal. This is also example of square matrix. Either it will be 3 by 3 or 2 by 2. These are examples of square matrix. Got it? 1, 2, 3, 4, 5, 6. Suppose this is assume A. Do you aware of A transpose? Bother about it. Right. See, A transpose means this is called transposition. Okay, transpose of the matrix. Transpose of the matrix means rows becomes columns. Rows becomes columns. Column becomes rows. So first row becomes first column.
First column.
Second row becomes second column. So A transpose means 1, 2, 3, 4, 5, 6. This is the result of transpose. Got it?
Yes, sir.
Identity matrix. With 1, 0, 0, 1. Whether you are aware of this one? Identity matrix. I stands for identity. Identity matrix. So this is first letter is I. So identity matrix indicated by I. And depends on order. What is the order here?
2 by 2.
2 by 2. That's what this identity matrix is called I2. Okay. Now I3 means 1, 0, 0, 0, 1, 0, 0, 0, 1. This is called I3. Okay.
I3.
What is the order here? 3 by 3.
3 by 3.
Correct? 3 rows, 3 columns. This matrix name is I3.
I3.
A matrix which is identity which has a order 2 by 2 is called I2. So now one specialty it has, the identity matrix. If you multiply any matrix with identity, we will get same result.
Same will get identity matrix only.
Same matrix will get. Suppose 1, 2, 3. Let us imagine A is equal to 1, 2, 3, 4. I is equal to 1, 0, 0, 1. See, depends on order we have to choose either I2 or I3. Here given matrix is A, which is consist of order 2 by 2. That's what I am choosing identity with order 2. That is 1 0 0 1. Got it? Now observe here. A into I means this is 1 2 3 4 and along with 1 0 0 1. Now observe the procedure of multiplication. First row, first column. Okay.
Yes.
First row, first column. So 1 into 1 into 1 plus 2 into 0. Then come to the first row, second column.
Yes.
1 into 0 plus 2 into 1. Now after completion of two columns, come to the second row. So second row, first column. Second row, first column. Now you have to do the simplification part. Now this is 1 plus 0 means 1 only. Correct?
We'll get
Now
the
this
same
is 3. Yes, you will get same matrix. Correct? It is equal to A. 1 2 3 4. Same matrix will get. So this is the property. So whenever you are taking one matrix, multiply with identity, it will give the same matrix.
Yes.
Okay, so this is the one of the nature. In EAMCET or competitive examinations, they will ask that A into I is consist of dash. So option A dash, option B, A dash, whole dash, option C, A inverse, option D, none. Which one is your answer?
Wait, okay, it will be the first one, no, sir.
Here, A dash in sense transpose of the matrix, correct? A dash in sense transpose of the matrix. What is the transpose of the matrix here?
It's the rows into columns, which we make column into rows. Okay, so it will be
Yes.
A dash into dash.
Yes, A dash, whole dash. So
Yes, sir.
A dash, whole dash means it will give same
It is
result
A
A.
only.
So option B is the right answer. So
Yes.
once you aware of this, you may give the answer properly, correct? If you don't know this property, we are not able to get the answer. Shall I raise this one? Now, product of two matrices, what is the rule we have to follow? That we are going to discuss. Product of any two matrices. Suppose if I am giving 1 2 3 and 4 5 6, can we able to do this production of these matrices?
Yes,
How
sir.
we have to check? How we have to check? See, there is a rule for product of matrices. See, first matrices, what is the order for this one? For this matrix?
It is like only one column is there, no, sir.
One row,
Sorry,
three
one
columns.
row,
1 by 3. Now this
Three
one,
by one.
3, very good. 3 by 1. So we have to check first matrices column number, second matrices row number should be equal. Should be equal. Then only product of two matrices is possible.
Yes.
Do you understand now? If given two matrices, they are asking about check whether product of two matrices is possible or not means in
We will check,
examination. Yes, in examination without solving any kind of problem, just to go through the order, we need to check first matrices column number, second matrices row number.
Row number.
We have to check whether both are equal.
If they're equal, we can multiply.
Yes, we can able to do the multiplication process, and as well as we can determine the result also, what kind of output we will get. See here, extremes we have to check 1 and 1 means 1 by 1 matrix we have to get. Got it? Now check how it will be possible. See 1 into 4, how much?
Into 4
4
plus 5
Plus
into 1.
2 into 5.
Sorry, 2 into 5 plus 3 into 6.
10, 3 into 6, 18. So 4 plus 10, 14 plus 18, 32,
32.
which is consist of one row, one column.
One column.
So the result also we can able to determine without doing any problem. Got it? This is the advantage. When we know the process, when we know the condition, what is the condition? In a first matrices column number,
Column number, and then
second
we have to see the
matrices
row
row
number.
number
If
should
they're
be
equal, we can
equal.
multiply.
Yes, yes. As well as we can able to know the output of the matrix, what kind of result we will get, what kind of matrices we will get. That also we have to determine. Correct?
Yes, yes, sir.
Now, in this, if A transpose is equal to A, this is called symmetric matrix. Symmetric matrix. In sense, suppose A is equal to 1 0 0 1. If you transpose, what happens?
It just it becomes 0. No.
Same thing will come. Correct?
Yeah, same
First
thing
row
only.
become first column, second row becomes second column, then 1 0 0 1. Same thing will happen. Correct?
Yes, yes,
So whether we can able to write here A,
yes, sir.
even though we transpose transpose of this one, A transpose is equal to A. So this kind of matrix is called symmetric matrix.
Symmetric.
Now see 1, 2, 5, 3, 2, 6, 7, 8, 4. This is a given matrix. They are asking about trace of the matrix. They are asking about trace of the matrix. Trace of the matrix means first we have to know about the diagonal of the element. Diagonal elements. What is the diagonal elements? See, this is the first row. This is the second row. This is the third row. So first row, first element. Second row, second element. Third row, third element. These are called diagonal elements.
Yes.
These are called
Diagonal
elements. Now, trace of the matrix in sense. Trace of the matrix in sense. Sum of the diagonal elements. Sum of the diagonal elements. So now tell me, sum of the diagonal elements. What is the result?
7.
1 plus 2 plus 4. It will be
4.
give 7. So trace of the matrix value is what? 7.
7.
Right. So this is the concept. Trace of the matrix means we have to know that sum of the diagonal elements is called trace of the matrix. So in entire matrices, just go through the definitions, then make it implementation. That's all. Then we can get easily. Got it?
Yes.
Now, if you check with this property, what kind of property we can able to call this one? We can call associative, right? Now, if we can say AB is equal to BA, then what we can say? Commutative property, commutative law. Then we have A into B plus C is equal A into B plus A into C. This is called what? Distributive property. So in examination, competitive examination, they may ask that given options, suppose they will give AB is equal to BA, A plus B is equal to B plus A minus B is equal to B minus A, then none. So among given options, which is follow commutative in terms of multiplication, means A into B means what? Multiplication only, correct?
Yes, sir.
A into B means what? Multiplication only.
Multiplication.
And they are asking about commutative law, particularly multiplication. And
Yes.
B option represent what? Sum of the roots, correct? Sum of the matrices.
Yes.
So it won't exist. A minus B means differences of the matrices. It won't exist.
That also won't
So
exist.
first one alone
First one
exists.
is correct.
A into B is equal. Yes, first one is right. So this kind of, if you aware of this properties names, then we can able to do answer easily. So this property name is what? Distributive property.
Yes.
So associative, commutative, distributive. 3 properties it follows. So up to now, whatever we discuss, product of 2 matrices, how it is possible, and types of matrices we discuss, correct? Types
Yes.
of matrices. How many types of there? What we discuss up to now? First one is row matrix, correct? So a matrix which consists only single row is called row matrix. Single row alone it calls row matrix. So a matrix which is consists single column is called column matrix. A matrix which is number of rows and number of columns are equal is called what?
Square matrix.
Square matrix. Excellent. So either it may 3 by 3 or 2 by 2. Now identity means what? I2. I2 means 1 0
1 0 0.
0.
I3 is 1 0 0 0 1 0 0 0 1.
So we, along with the identity, what we learn? Any matrices multiply with I, it
I
will
is
use
equals to
the
A.
same matrix, correct?
And any transpose of a matrix is equals to A.
Yes, A transpose is equal to A. This property name is what?
Transpose,
Symmetric.
Symmetry.
Matrix. So trace of the matrix means what?
Trace of the matrix is the diagonal elements of the matrix.
Sum of the diagonal elements.
Sum of the
So
diagonal.
for example, if you take this means 1 plus 1 plus 1, which will be gives 3.
3 is a trace of matrix.
3 is the trace of the matrix. So this kind of learning we need for competitive
Yes.
examination. So basic funda we have to know and properties we have to know, then make it implementation, we can go through that. Then it is easy for us to the competitive examination. Got it?
Yes.